Hey everybody. So we're looking at 4.5 solve absolute value equations. So yes, we're getting into absolute values today. And so I guess before we get into it, go ahead and get the title at the top of your paper. Go ahead and copy this slide and we'll get into it. Okay, so this is asking what is the absolute value of 4 and negative 4? Okay, when they ask us for the absolute value of a number, what does that mean? Okay, here's what it is. Basically, the absolute value of a number is its distance away from 0. Okay, which, sorry, this was covered up. If you want to copy this on your paper, you can. Okay, but yeah, that's what it means. The absolute value of a number is how far away from 0 on a number line is that number? How many, you can think of it, how many units away? Okay, well, if I'm talking about positive 4, this right here, which, oh, sorry, this got kind of shifted. Sorry, let me reline this up with the numbers. That looks a little better. Okay, so yeah, if we're talking about positive 4 on a number line right here, well, it looks like it's 1, 2, 3, 4 units away from 0. So the absolute value of 4 is 4. Okay, if we're talking about negative 4, this right here, notice that it is 1, 2, 3, 4 units away from 0. So the absolute value of negative 4 is also 4. Okay, so really that's the way of thinking about absolute values. It's the distance away from 0. Okay, you might have already known that, oh, the absolute value of negative 4 is 4. You might not have known maybe why. Okay, so that's technically what we're talking about when we're dealing with absolute values. But today we're going to look at them in context of equations. Okay, so let's take a look at this real quick. Go ahead and copy it. Okay, so here's the difference. This is kind of the opposite of what we were just looking at. This is basically saying the absolute value of x equals 4. And we're wondering, what could x be if the absolute value of it equals 4? Okay, well, we just, realized that x could be a positive 4 or x could be a negative 4. Okay, if it equaled 4. And that's basically what I would have as my answers. What I like to do is kind of split it using these arrows. Okay, but those are the two things. X could equal a positive 4 or x could equal a negative 4, right? Think about it. If we plugged in a 4 here, the absolute value of 4 is 4. If we plugged in a negative 4, the absolute value of negative 4 is 4. Okay, and technically we'll put a little or between these. So this is my answer to this equation here. It would be one or the other of these answers. Okay, so let's try it. Let's try it again using some, I guess, other examples. So take a second, copy this. All right, so on this problem here, it's saying the absolute value of x equals 7, and we're wondering what are the values of x? What could x be? All right, just like before, I'm going to go ahead and split it using my little arrows because I like my arrows. All right, and we know that x equals or could equal a 7, or x could equal a negative 7. All right, I guess the easiest way to think about it is we're always going to set what's inside of the absolute value equal to the positive and negative of whatever this number happens to be. X is going to equal a 7, x is going to equal a negative 7. So when we go to look at letter B here, it's going to be the same idea. I know that x can equal a positive 3 over 5, or x can equal a negative 3 over 5. Okay, and let's put some boxes around these because they're our answers. Right. So that's how we go about, I guess, breaking these things into our actual equations that we can solve. They're not always going to be this simple, but this is the fundamental idea. You're setting what's inside of the absolute value bars equal to the positive of this number and then the negative of that number. Okay. So with that in mind, go ahead and try out these two problems. See what you get for numbers 1 and 2. All right, so on this one, hopefully this was pretty simple. We know that x can equal a positive 15 or x could equal a negative 15. Okay, on number 2, same idea. Even though it's a decimal, don't let it scare you. We know that x can equal a positive 7.8 or x can equal a negative 7.8. All right, so that is the idea. What happens when things get a little bit more complicated? Let's see. Okay, go ahead, take a second and copy this. Okay, so inside of the absolute value bars, a little bit more, complicated numbers in there, but it still follows the same fundamental idea. I know what is inside of the absolute values is going to be set equal to a positive 5 as well as a negative 5. Those are my two equations. So let's go ahead and start with the positive 5. So I know that a 3x plus 2 can equal a positive 5, or my other arrow, 3x plus 2 can equal a negative 5. Okay, those are my two possibilities. Now I just need to solve them and I can figure out what x equals. All right, so let's start on the left here. Easy math, we've done this a lot, so I'm not going to take too long. Subtract 2 from both sides. It looks like we got a 3x equals 3. I'm going to do this in my head, divide by 3, and it looks like one of my possible answers is x equals 1. Okay, over here, same idea. I'm going to subtract both sides by 2. Looks like 3x equals a negative 7. Okay, divide both sides by 3. 3 doesn't go into 7 evenly, so this is going to stay as a fraction, and I'm going to get negative 7 over 3. Okay, technically there's an or between these, so try to remember that. It's not a huge deal, but just try to remember it. So those are my two possible answers for x. Okay, yeah, so let's go ahead and have you guys try out one of these. Go ahead and break this into the two equations, solve them, see what you get. All right, so here's the thing. We know that this 2x minus 3 is going to be equal to a positive 9, or this 2x minus 3 can be equal to a negative 9. All right, solving these, I'm going to do all of this in my head. Adding 3 to both sides, I have a 2x equals 12. Dividing both sides by 2, I have an x equals 6. If you can do that in your head, I am totally fine with it, but I still do need to see each individual step, just not necessarily the operations that you're doing, not necessarily writing them out. Okay, same idea. I'm going to do that on this. Adding 3 to both sides, I'm going to get a 2x equals a negative 6. Dividing both sides by 2, x equals negative 3. Okay, and don't forget that or in between. So there are my two possible answers. Okay, and you guys, as you can imagine, if I were to plug a 6 in here, I would get a 12 minus 3, which would be a 9. Yeah, the absolute value of 9 is 9. If I were to plug a negative 3 in here, I'd get negative 6 minus 3 is a negative 9. And yeah, the absolute value of negative 9 is 9. Okay, so that's why these are actually answers. And you can always check them if you really wanted to. You don't need to, though. Okay, so let's keep moving on. What happens, I guess before I get to it, go ahead and copy this. Okay, so what happens on problems where we have numbers outside of our absolute value bars? Okay, before we had problems like this, okay, but now we have a number on the outside. Okay, here's the thing. We can only break this thing into the two problems. And by break into two problems, I mean doing this arrow thing when we have our absolute value completely isolated. Okay, on this practice problem, it was by itself. We broke it into two problems. On this problem, it's not. We have this 4. So before we can do anything, we need to get rid of this 4. Okay, and we're going to get rid of it like we always do. This 4 is technically being multiplied by the absolute value. So to get rid of it, we're going to divide it from both sides. Okay, now it's gone. We have the absolute value of t plus 9. Don't forget those absolute value bars. They're still there. Okay, over on the right, 24 divided by 4 looks like we have a 6. Okay, now that we have our absolute value isolated, now we can go ahead and split it into the two equations. Okay, so I know that t plus 9 is going to equal a positive 6, or t plus 9 is going to equal a negative 6. Okay, and you probably already noticed this, but when we break it into the two equations, the absolute value bars, they disappear. That's why I guess we break it into the two problems is to get rid of the absolute value bars. Okay, and then easy math here, subtracting both sides by 9. It looks like t is going to be equal to a negative 3. And again, subtracting both sides by 9, it looks like t is going to be equal to a negative 15. Right, or. Okay, and I just want to point out again, if it does help to show -9, -9, and then, on both of these, it's not a bad idea. I'm being kind of lazy, but I would suggest, especially on a test, showing this step because it's really easy to make mistakes if you don't show yourself what you're doing. Okay. All right, so I'm gonna have you guys go ahead and try out one a lot like that. Make sure you isolate the absolute value before you break it into the two equations. Try it out. All right, so just like before, we have this 4 on the outside. We need to get rid of it. It's being multiplied by the absolute value, so I'm going to get rid of it by dividing. Okay, so if they're gone, I have the absolute value of 2k plus 3. Over on the right, looks like I have a 2. Okay, now that it's isolated, now I can go ahead and break it into the two equations. All right, so I know that a 2k plus 3 is going to be equal to a positive 2, or a 2k plus 3 is equal to a negative 2. All right, so on this one, I can see I'm going to get some fractions. So I'm going to write out my steps because it's easy to mess up. So I've got a 2k equals negative 1. And when I go to divide by 2, it looks like I'm going to be getting a k equals a negative 1 over 2, a negative 1/2. Okay, on this one, same idea, subtract by 3. Oops. Looks like I have a 2k equals negative 5. Okay, dividing both sides by 2, looks like k is going to be equal to negative 5 over 2, or negative 5/2. Okay, and there we have it. And let's not forget our little or sign. Okay, so let's just keep going. We have a couple more that just get more elaborate. Let's take a look at this example. Go ahead and copy it. All right, so again, our absolute value is not isolated. We need to get rid of both of these numbers, a -3 and a -7. Okay, here's the thing. We need to get rid of them in the correct order, and we get rid of them in the order as if this thing was an equation. Here's the way of thinking about it. Think of this absolute value as a giant variable. What if this was a negative 3x minus 7? Well, we deal with addition or subtraction first. We would get rid of this -7 first. Okay, we're going to do the same thing here. So I'm going to go ahead and add 7 to both sides. Okay, if they're gone, I'm going to bring down what I have, a negative 3 times the absolute value of n plus 2 equals negative 10 plus 7 gives me a negative 3. Now I can get rid of my negative 3 that's being multiplied by my absolute value by dividing. Okay, in my brain, I was like, oh, I divided by a negative. I should flip away, but it's just an equation, not an inequality, right? Okay, so they're gone. Absolute value of n plus 2. Don't forget the absolute value bars are still there until we break it into two equations. Negative 3 divided by negative 3 is a positive 1. Okay, now we can go ahead and break this into the two equations. I know that an n plus 2 is going to be equal to a positive 1, or n plus 2 is equal to a negative 1. Right, and then pretty easy math, subtract 2 from both sides, looks like m equals negative 1, or subtract 2 from both sides, and equals negative 3. All right, one thing you've probably noticed, but I really want to point out, the values that are inside the absolute values, they never ever change. They never change, even if they were negative numbers. Say this was a negative n plus 2. This would still be a negative n plus 2 equals 1, and a negative n plus 2 equals negative 1. Okay, what's inside does not change. It doesn't matter what it is, just so you know. All right, so I think I'm going to have you guys try one on your own. Yeah, okay, same idea. Go ahead, get rid of both of these numbers, and then break it into the two equations. Give it a try. Okay, so hopefully you noticed, all right, we have to deal with the 6 that's being subtracted first by adding 6 to both sides. Okay, they're gone. I have a negative 3 times the absolute value of 5g plus 1. Okay, and careful, those absolute values, sometimes they start to look like 1s, so just make them longer than everything else. Over on the right, looks like a negative 3. Okay, and let's see, dividing both sides by a negative 3. Looks like we're getting the absolute value of 5g plus 1. Well, 5g plus 1 absolute value equals positive 1. All right, now I can break into my two equations. 5g plus 1 equals positive 1. 5g plus 1 equals negative 1, right? Okay, and then solving these things, let's see what happens. So subtracting 1 from both sides, looks like I have a 5g equals 0. Divide both sides by 5. Just a reminder, guys, whenever you have 0 divided by any number, you just get 0. Okay, so g equals 0. Or when I go to do this, subtracting 1 from both sides, I get a 5g equals negative 2. Divide by 5, g equals negative 2 over 5, right? Or negative 2/5. Okay, last type of problem. This is kind of a special case one. Go ahead and copy this and we'll try it. Okay, solve if possible. If possible. Why do they say that? Okay, let's figure it out. Okay, so just like before, I'm going to go ahead and isolate this absolute value just like always. Okay, the 6 is being added, so I'm going to get rid of it by subtracting. All right, so they're gone. I have the absolute value of 3x plus 5. Over on the right, I have negative 2 minus 6, which gives me a negative 8. Okay, here's the big thing. If you guys remember, going back to the very first slide, anytime we take the absolute value of something, we always got a positive number. Positive 4, positive 4. When you take the absolute value of something, you will always have it set equal to a positive number. All of these were positive. And the reason why is because if it's not positive, we cannot do the problem. Okay, there's no way to solve this equation. Okay, because yeah, it's set equal to a negative number. Okay, so that means there is no value that x can equal, or in other words, no solution. Okay, cool. So yeah, look out for those. Most of your problems with this will be a positive number, but just look out for when it's negative. Also be careful. Sometimes it'll be negative here, but then you'll isolate the absolute value, and then it'll turn into a positive number. So don't think, oh, it's negative, I'm done. No, actually isolate the absolute value and then see if you have a negative number still. Okay, cool guys. So that's today's lesson. I will see you back in class. Bye.